Afternoon, everybody. Today we are discussing the next topic, that is the conformations of ethylene glycol. So we have discussed the conformations of the ethane and butane. So from that we have understood that the antiform is the most stable form, and here we are discussing the important conformations of the ethylene glycol. See, here we can see the four distinct conformations of the ethylene glycol. First of all, we have to mention the molecular formula of the ethylene glycol. The molecular formula is OH, CH2, CH2, OH. Then we wrote down the sum of the conformations of the ethane. So there are four distinct conformations. First one is anti or fully staggered. Second one is fully eclipsed. The third one is eclipsed, and fourth one is the gauge form. So in the ethane and butane, the most stable conformation is the anti or the fully staggered form, since it shows the least torsion strain and least angular strain, and it also shows the least steric strain. But here in the fully staggered form, this is true. Both the group are as the maximum distance apart, so it is devoid of the torsion strain, angular strain, and steric strain. But the most stable conformation of the ethylene glycol is the gauge form. This is mainly due to the existence of the hydrogen bond beyond these strains. See here, in the gauge form only the hydrogen bond is existing because the two OH group are 60 degree apart. So that is in the bonding distance. So that's why there exists a hydrogen bonding in the gauge form of the ethylene glycol. So that's why the gauge form is extra stable in the conformation of the ethylene glycol. Now we are moving into the next important topic, Bayes strain theory. So in a cyclic compounds, for example cycloalkanes, we know that the simplest cycloalkane is the cyclopropane, and the remaining other cyclic compounds are the cyclobutane, cyclopentane, cyclohexane, like that. So if the molecule exists in a tetrahedral geometry, definitely the bond angle must be 109.5 degree. So according to Bayes proposed that there is a instability is existing in the 3 and 4 membered ring, which is mainly due to the angular strain. We are already studied the angular strain, and definition we are already studied. So in the cyclopropane, we can see that the bond angle is 60 degree, and which is less than 49 degree less than that of the ideal tetrahedral bond angle, that is 109.5 degree. And in the cyclobutane the bond angle is 90 degree, that means it is less than 90 degree less than that of the ideal tetrahedral bond angle. So the angular strain is the strain which is induced in a molecule when the molecule deviate from the tetrahedral bond angle of 109.5 degree. So according to Bayes' concept, cyclopropane is unstable and cyclobutane is also unstable, and every other cyclic compound is unstable, because if we are forming the cyclic compound, we have to stretch the CC sigma bond very close to each other. So it is deviating from the bond angle, tetrahedral bond angle. That's why every cyclic compounds are extra strained system according to the Bayes theory. And he proposed his theory, that is, the first point is bond formed by a carbon atom with 4 other group or atoms are oriented in a tetrahedral fashion, so that the bond angle between any two adjacent bond is 109.5 degree. Okay. The second point, in a carbocyclic compounds, the carbon atoms that constitute the ring lie in the same plane. Okay, in the cyclohexane we know that every carbon, in cyclopropane we know that the three carbon atom exist in a single plane. See here, all the three carbon atom exist in a one plane. In the cyclobutane also all the four carbon atom are exist in a single plane. Next, third point in the Bayes strain theory state that the CCC bond angle in a planar ring cannot be equal to the tetrahedral angle of the 109.5 degree. So that the deviation from the desired bond angle of the 109.5 degree causes some strain, and this strain is known as the angular strain. See here, I already told you that in cyclopropane the bond angle is 60 degree and it is 49 degree less than that of the normal tetrahedral bond angle, that is 109.5 degree bond angle. So the cyclopropane is really unstable. Similarly, the cyclobutane, the bond angle is 90 degree. It is 90 degree less than that of the tetrahedral bond angle, that is 109.5 degree. So that these rings causes some angular strain. And the fourth point, the angle strain in a ring of a carbon atom contribute to its instability, and the strained ring compound tend to be unstable as compared to the compound in which the bond angle are equal to tetrahedral bond angle. See here, this is the propane molecule. The first one is the propane molecule. The bond angle is 109.5 degree. We know that the propane is highly stable, and according to Bayes, he told that the propane is extra stable due to the carbon attain the tetrahedral geometry, whereas in the cyclopropane, the ring is highly strained because it is deviating from the tetrahedral bond angle. That's why it is highly strained system. So according to Bayes strain theory, when a molecule is deviating from tetrahedral geometry, it attains the extra strain. And fifth point, greater the deviation of the bond angle of a ring from the tetrahedral angle, greater is the strain and greater is the stability of the instability of the ring. And the last point, higher the stability of the ring, the smaller is the angular strain in the ring, and greater would be its ease of the formation. See here, the cyclopropane shows the maximum deviation, that's why it is highly unstable. But whereas in the case of the cyclobutane, the bond angle is 90 degree, so the deviation is less. That's why the cyclobutane is more than stable than that of the cyclopropane. Okay, hope you understood that concept. Thank you.